Hello and welcome back to module number 7. This module we're going to talk about visual distribution, but we will do all our visual through the eyes of R. One of the websites that I gave you to review is using R to display distribution. So he lay out exactly example how to use the R to show distribution, and I hope you will enjoy it and be able to take away from it. In Canvas, I also posted some code that allowed you to do example distribution, car distribution by year versus the number of years. And one of the things that you're going to see is a code or data set called empty cars. It is a very popular database that shows the distribution of cars. And again, this is something that you will encounter in your assignment. So I hope you will enjoy that. Back to our subject and back to our framework of what we are going to do today. So we are going to talk about distribution, and again, just one note, both textbooks, and I'll give you the reference in the Canvas about reading them. Each textbook look at that differently, but it is interesting to see that and to see how to measure distribution with regard to frequency, with regard to categories, with regard to central tendency, and I will try to explain that through the use of R. Okay, so distribution of statistical set is a listing of functions showing all possible values of the data and how they occur. So the idea here is that we take distribution, we usually break down the distribution based on categorical data and see the category, how they presented in the distribution. So we, in the visual space, when we take the distribution and try to display it as a visual display, we are talking about the shape, we are talking about location, and we are talking about the spread. The shape is the shape, show how the variance of the distribution is about the location. The location is about the expected value of the output, and the spread is the expected amount of variation associated with the output. So I lay out for you what is its stand, what is the type of visualization often involved in it, the spread, what does it entail, what type of visual we often display, and the idea of, again, location. If you are looking for location, there is a specific type of visual that actually very common. Most of the common visualization that about distribution, we are talking about box plot and histogram as the foundation of our argument. However, we also can apply scatter plot, which is also quite nice, but if you look closely into the data or the visual, he spread it or classify it into three type of categories in order for us to show the distribution of the data. The shape is about the distribution, about the location, and again we have different type of shape and how we sort the shape, and again this is how we look at that: systematic, uninformed, to the left, to the right, and how we apply that. Again, box plot is another example, and it's also very popular tool or visual to display distribution and how to do that. When we are talking about distribution, one of the things that we often talk about, we're talking about frequency distribution. And we are often define the frequency distribution by two: ungroup frequency distribution and group frequency distribution. And most of them have some say of it. Example, course taken. So ungroup can be spread all around. Age of voters can be grouped. Example, 18 to 30, 31 to 42. It's much more much more sorted in order for us to understand that. But again, This is part of the distribution. This is part of where the visual can help user from the outside to understand the data. And again, this PowerPoint show you a lot of example of how to apply that, what does it entail, and how we measured frequency distribution, which is, I hope by now you remember that it is class frequency divided by sample size, f divided by n, and which will give you the idea what it entail and how to look at that. And again, this is part of the source, how to look at that and how to apply to it. You're going to have the option to download the PowerPoint presentation, so you be able to go over each one of them and to think about what is the group and ungroup frequency distribution and what does it entail. Another thing about distribution, another tool that, or statistical terminology that we have about distribution, is the idea of central tendency distribution. It is the idea that we use in descriptive statistics to describe the average or the typical value of a set of scores. And there are three common measurements of the central tendency: the mode, the mean, and the median. And all of it, again, this is a repetition of what I talked about descriptive statistics. The same thing about that, and in this PowerPoint, you will have more time to go over each page and to see what is multi-dimensional distribution when we are talking about central tendency. So again, the idea of central tendency, what does it entail, how to define it, but we also need to think about the variables, one versus multiple variables in our database, in our data set. And one of the better way for me to think about visualization is this cake bakery and how they sort what they bake most often. And they learn very quickly that Thin Mints is the best cookie that they have. It's the most popular one. And again, this is a way for us to visualize it or to describe the visualization. When we are talking about single variable visualization, we are often talking about, when it is single, we are talking about histogram. Why? It shows the center, it shows the outliner, and it shows it shows us the position of all the variable that we are trying to establish. But there is issues with histogram. For small data set, histogram can be misleading. Small changes in data can be misled. Large data set can be inefficient with regard to illustration of the general property of the distribution. And when we are talking about the histogram efficiency, work with one variable at a time, and that's how we need to see the variable itself. So be careful when we are talking about the axis in histogram and the scale of it in order for us to verify it. And again, one of the things that we often use in histogram is the smoothness histogram or the density estimate. And it's a formula, and then we can apply that into the visual in order for us to have a sense of how the distribution is being estimated. And again, this is the idea of how can we apply visual to explain us about the distribution. In R, it's quite simple because it's all come down to how we set it up and what does it entail. So when we want to color the histogram in simple in R, we will say color red, and we will say we want to break the data set, in this case again empty cars, into 12 set in order for us to do that. Now it's when we want to have a normal curve adding to the visual, It means that we will see how the distribution, normal distribution, compared to what we have in our distribution. This is what the R is so good at. Adding an additional dimension to the visual in order for us to explain or to illustrate what is how a data set is matched up with normal distribution. Box plot, again, time series, it's again the power of the idea of histogram and ability to apply that into it. And again, this is something that we often see with regard to distribution, how the distribution is being captured, and we often talk about that when we are trying to see, example, who consume vegetables throughout the year, what state. So this is the distribution. But what happens when we have more than one variable, and what the type of variables that we want to apply to in order for us to illustrate that. So we have different application with regard to the visual display and how to apply that, but you have to show that X and Y, the two set, actually talks to it another or display it in order for us to do that. So when we have no apparent relationship between X and Y, this is something that we often encounter. And when we have a linear relationship, this is what we see. And again, the power of the visual is the idea to catch this relationship without even calculate, because the visual display everything allowed us to do that. Again, the PowerPoint presentation talks about other type of variables when we are trying to match or to see if there is a relationship between the two variables. And again, displaying the two variables can be quite interesting when we are trying to see the difference between one to another. In this example, true versus false. And again, two categorical data variables or one categorical data variable can be applied to R in order for it to match. Something that Excel or SPSS does not play so well with when we are talking about displaying two categories. One of the things that is, again, scatter plots is really popular with regard to distribution. How is the distribution overall? It's a powerful tool, and I highly recommend that you will use to apply that and to learn how to apply that, because it can be a powerful tool. Multivariance, again, is the issue of how to display it, how to apply that. We can do that in different ways in R, and I will show you. Or you can, again, look at the website using R to display this distribution. And again, it show you specific example, how to apply it, how to coordinate it, and how applying coordination in order for us to do that. So parallel visualization of iris data. Again, this is something that I want you to be inspired, and we will cover in the upcoming classes. We will also cover network analysis and how to apply, and we will see again the issue of R and what R can do to us, help us in order for us to do that. So again, one of the common issues that we often talk about in visualization, what is missing? Pie chart is very popular, but there is a good for showing simple relation. But what about when we are missing information or missing data? How can it apply? That's something that a pie is sometimes really bad. 3D, again, this book does not like 3D, and he has make a point that I hope that by now you understand that is sometimes can be misleading. And so it is nice to show 3D, but when it's done poorly, it can cause a lot of misunderstanding by the user that is watching your visualization. Worst graphic in the world with regard to the distribution, again, this is example of misunderstanding. We do not understand where's the distribution, what is good, what is bad, and the visual does not help us to make it more sense. So again, this is examples of how to make it more, where is it bad, but the dimension reduction is a way for us to move away from 3D or 2Ds and make it straightforward as much as possible. One of the things that I would like you to look at is Hans Rosling. 2 years ago he died. He was a Norwegian scholar that always talked about how to visualize data that he collected about population and distribution of population, which is again a subject of a module. And in this video, he talks about that, how it can be applied. I hope that you will have time to watch it because it's really good. So best practices in visual or distribution: keep internal consistent. Select the best interval in order for us to show the user what you have found. Use measures that resistant the outliner, which means try not to focus too much on the outliner because it will not show the distribution itself. And again, I broke down this component and how to example from the book and what he tried to do. Based on a few, the top histogram is only one with consistent of size, age, and interval. So again, try to do your best when you are trying to apply histogram, and try to select the best interval when you are trying to show something that it make more sense. Using measurements that are resistant to the outliner, again, try not to focus on the outliner, try to focus on the main distribution. That's it. That's all the module. I posted on the Canvas. I posted example of the code. I also downloaded the Metacars data set, but you can run it in R because it's part of our user RStudio data set, so you can be able to do that. And try to talk about, when you post your blog, try to talk about what is it in Intel, how did you create it in R or in other platform, doesn't matter, and talk about the visual structure. What does it entail? Why did you choose that as the best way to visualize or to capture the data in this way? I want to see more in-depth discussion by you about the visual display. That's it for now. I hope you enjoy it. I hope you learn, and I will see you next time.